This is Chapter 13, the gas laws. The first thing we need to talk about is atmospheric pressure. Remember that air is matter, and because it's matter, it has weight and takes up space. Okay, and since it has weight or mass, air, due to gravity, pushes down on us. So even though we don't feel it, there is always air pressure or pushing down on the earth and on our bodies all of the time. And a fellow named Torricelli invented something called the barometer, and he figured out a way to measure the pressure of the air. He took a tube and filled it up with mercury, and he put it down in a little bowl or can that also had mercury in it. And when he took that tube that he had filled up with mercury and inverted it, the mercury went down in the tube, creates a little vacuum up here in the top part. But the pressure from the air pushes down on the mercury in the can and keeps a column of mercury pushed up in the tube. And he found out that at sea level, the column of mercury that stayed up in the tube was 760 millimeters high. So there's 760 millimeters of mercury sitting up in that tube. Now, if you go up high in the mountains, like in Colorado, say 9,600 feet, or above sea level, you would find that that column of mercury is only 520 millimeters high. And that's because the pressure of the air is not as strong up there. Okay, so the air is not pushing down as much at 9,600 feet as it is at sea level. So 760 millimeters of mercury is known as standard atmospheric pressure. Okay, so in the gas laws, when we talk about standard pressure, we're talking about 760 millimeters of mercury in this column. Let me give you some conversions that we're going to be using. So 1 standard atmosphere, STD is standard, ATM is atmosphere, equals 760 millimeters of mercury, or it's also called 760 torr, named after Torricelli, who invented the barometer. These mean exactly the same thing, millimeters of mercury or torr. There's no difference. The SI unit for atmosphere is called a pascal. And we normally in chemistry will use atmospheres or millimeters of mercury, but we also need to know pascal. So 1 standard atmosphere is equal to 101,325 pascals, abbreviated PA. So Pascal is very, very small. It's also equal to 101.325 kilopascals. And then the other thing that's good to know, although we won't be using it in calculations, 1 standard atmosphere is equal to 14.69 psi, which is pounds per square inch. Okay, and this is the measurement they would use when they put air in your tires. This is also the measurement that engineers would use, the PSI. But for us, we're going to mainly use standard atmosphere, millimeters of mercury, and maybe sometimes pascals. So that's what we need to know about atmospheric pressure. The first gas law that we're going to learn about is called Boyles' law. And Boyle discovered that at constant temperature, the volume of a gas decreases as the pressure increases. So if you look at this little graphic we have, it's a little bit fuzzy, but think of this as a little piston type thing. It's got a little lid on it that can go up and down freely, and it's not hindered by friction or anything. If you put a liter of gas in there, and I'm going to write this again just so you can see it a little bit better. So if you have 1 liter of gas and you have a pressure of 1 atmosphere, and you take that same piston and you double the pressure so that now you have 2 atmospheres of pressure, you would actually cut the volume in half. So now you would have 1/2 of a liter. And then you could do it again. You could double the pressure again and go to 4 atmospheres. And that would give you a volume of half of that, of the 0.5, which is 0.25. So every time you double the pressure, you half the volume. And so Boyle did some experiments and discovered that that's what always happened if you use the same amount of gas, the same number of moles of gas or number of molecules. And so what he discovered was if he took the pressure times the volume of each one of these, he would get the same answer every time he multiplied them together. So for instance, pressure times volume, here you have a pressure of 1 atmosphere times a volume of 1 liter. That gives you 1 atmosphere liter. Here you have a pressure of 2 atmospheres times 1/2 of a liter. That still gives you the same answer of 1 atmosphere liter. And here you have 4 atmospheres times 0.25 liters, and that gives you the same answer, 1 atmosphere liter. So he realized that this and this and this, the same gas at constant temperature, would give him a constant. So he said P times V equals a constant number. And because of that, because this one and this one are exactly the same, then he could say P1 times V1 equals P2 times V2, which would equal P3 times V3. So this is the law that Boyle actually came up with, and we call it Boyle's law, to show that the pressure is inversely related to volume. Okay, so in other words, as pressure goes up, volume goes down. as pressure goes down, volume goes up. When Boyle plotted this data on a graph, volume here and pressure here, you got something that looked like this. So as the volume was high, the pressure was low. As the pressure increases, the volume gets smaller. Now, knowing that P1V1 is equal to P2V2, if we have a gas at a certain volume and pressure and constant temperature, and we change the pressure, then we can use this equation to figure out what the new volume would be. Or we could change the volume and figure out what the new pressure would be. So I'm going to do an example 13.2, and you can look at it in your book also. But basically it says we have a 1.5 liter sample of Freon, so that's our volume, and we have it at a pressure of 56 torr. Okay, remember, torr is the same as millimeters of mercury, so in other words, the little tube of mercury that's sitting in the barometer would be 56 millimeters high. And we're going to change that pressure to 150 torr, which means we're almost tripling the pressure. Now think about this. If you're almost tripling the pressure, what's going to happen to the volume? Remember, as the pressure goes up, the volume goes down. As the pressure goes down, the volume goes up. So we are increasing the pressure almost 3 times, which means that the volume is going to go down almost 3 times. So if we have 1.5 liters here, then when we calculate V2, we should have something around 1/2 liter. So let's solve. We need to solve for V2. The first thing you need to do when you do these problems is you need to write this out, write out what you have, then take your equation and rearrange it so that you can solve for whatever you're looking for. So if we have P1V1 equals P2V2, and we want to solve for V2, we have to get rid of P2 over here. So we are going to divide both sides by P2, and that's going to cancel them out over here, and we're going to end up with P1V1 over P2 equals V2. Okay, so that's the equation that we need to solve this example. And then all we have to do from that point is just take our values that we have written over here, plug them into this formula, and we should get our result. So P1, put the little 1 here. P1 is 56 torr, so we're going to put 56 torr here, times V1, which is 1.5 liters, divided by P2, is 150 torr, and that should give us V2. Okay, our torrs cancel, which means we're going to end up with liters, and that's what we want because we're looking for volume. And when you plug those numbers in, you should get 0.56 liters. Now look at that. 0.56 liters is about 1/3 of 1.5 liters, right? And that makes sense because we took the pressure and we increased it 3 times, which means that the volume is going to decrease about 3 times. So that's your answer to the Boyle's Law example.